We're gonna walk through a couple quick diagrams of this in the slides. This does use pseudocode. I've shortened a lot of things. It's not T-SQL that will actually run just for the sake of keeping the code small. For this example query, where we want the employee key, where the last name equals G and the first name equals A, SQL Server identifies, hey, I've got a great index for this. It has 3 key columns, but the first key column is last. You know, our predicate in the query is the first key column. So this is a great match for this. The index also has somewhere in it, it has employee key and it has the first name. So it can get all the data from this index. The query is covered by this index. So I'm going to go to the root page of the index, and then I'm going to use the guideposts on there. If the last name is G and the first name is A, that's before the guideposts I have for last name G, first name M. So I can go to the page before that, I can seek to the leaf, and I can get the data that I need. For another query, if I want the last name where the first name is A, the optimizer will look around and say, hey, do I have an index that leads on first name, where the keys lead on first name? But I don't. I do have an index where everything's sorted first by last name, and then the first name column's in there, but it isn't the first column listed in the key. So it's not great, but it's probably better than scanning the base table if I compare how large they are. This index, I figured out it is smaller. So I'll go to the root of the index, and these guideposts don't help me a whole lot because everything is sorted first by last name. First name A could be all over this table, or there could be no rows for it as far as I know. So I'm going to go to the first page in the leaf, and then I am just going to follow the pointers through the leaf and read all the pages in the leaf and feed the rows into a filter and check all the rows and be like, is your first name A? Is your first name A? Is your first name A? And the great news about this is our index isn't designed to handle this query perfectly, but SQL Server can still use the index. And I think that's fantastic that it's flexible enough to do that. Similarly, imagine we have an included column whose name is include. It said it was pseudocode. So imagine that this table has an included column named include, and we're searching on that. Well, it will try to see, do I have an index where include is not an included column, where it's the first column in the key? We do not. But this index has the included column. The root page doesn't have any information to help us. It doesn't even have included columns, but it does have information to help us. It'll help us get to the first page in the leaf, and then we can scan all the pages in the leaf, which have the included columns. Among those included columns is the column named include, and we can run a filter and check for each row. Is include equals E? Is include equals Z? Very flexible and very smart, and I love that it can use those indexes in those ways.